Question 2. Niram, Olivia, and Phil all enjoy exercising and often go to a path along the river for this purpose. Niram bicycles at a very consistent 40.25 km per hour. Olivia runs south at a constant speed of 16 km per hour. And Phil walks south at a brisk 6.5 km per hour. Niram starts biking north at noon from the waterfalls. Olivia and Phil both start at 11:30 a.m. at the canoe dock 20 km north of the falls. Draw position time graphs for each person. Then there are two other parts which we will look at later on once we draw the position time graphs. There's lots of information here. Let's draw a sketch of the situation which will help us in drawing the graph. The motion is along north-south, so let's choose upward direction as north and consider that to be positive. Canoe dock is north of the falls. So if waterfall is here, let's say canoe dock would be here. Let's represent Niram by N. We have Niram starting at the waterfalls. Olivia and Phil are at the canoe dock. The distance between the falls and the canoe dock is 20 km. Let's label this distance. Let's choose Niram's location to be origin. So Niram's initial position would be 0 km. And Phil and Olivia's initial position would be plus 20 km. Olivia and Phil start at 11:30 a.m. So their initial time would be 11:30 a.m. Let's map that to 0. Then Niram's initial time would be 0 0.5 hours because he starts at noon. 11:30 a.m. we have chosen to correspond to 0. So noon would correspond to 0.5 hours. What about all the velocities? Let's gather that data as well. Velocity of Olivia, velocity of Phil, and velocity for Niram. Olivia and Phil are moving southwards, so their velocities would be negative. Olivia is running at 16 km per hour, so negative 16. Phil is walking southwards at 6.5 km per hour, so we should write negative 6.5. Niram is biking north, so his velocity would be positive 40.25. Now we have the initial time and position as well as the velocities for all the three people. With this data, we can go ahead and plot their position time graphs. Let's start plotting the position time graph for each person. Here on the x-axis, I have time in hours and position in kilometers. Let's start with Niram. Initial location of Niram is 0 kilometers at the time 0.5 hours. That corresponds to this point on the graph, 0 kilometer at noon. Niram's velocity is 40.25 km per hour. So that's the slope. That would be a rise of 40.25 km in 1 hour. I do not have enough space on my graph here, so I can look at it. It's around 20.1 km per half an hour. So a rise of 20.1 km along this direction in 1 hour leads me to around this point. I join these two to obtain the graph. Olivia's initial location is 20 km when the time is 0. So on the graph, this starting point is here. And Olivia's velocity is negative. So the slope would be negative 16 km per hour. So a drop of negative 16 is here along the y-axis, and for 1 hour we obtain this point. So using the initial point and the slope, we are able to obtain the second point. We join these to obtain the graph for Olivia. For Phil, the starting point is same as that for Olivia. At 0 time, the initial location is 20 km. Slope for Phil is negative 6.5 km per hour. So a drop of 6.5 would be around here per hour. So the run along horizontal axis would be here, joining these 2 points. So this is the solution for the first part where we have obtained position time graphs for each person. We will work on the rest of the two parts using the graphs as well as equations. So let us get the equations of motion for each person. Equation of motion for an object moving in a straight line at constant velocity is given by final location equals constant velocity multiplied by the time interval plus the initial location. For Niram, let us represent his final location at any time be xn equals his velocity is 40.25. So 40.25 times the time interval. I will expand the time interval for Niram because he started half an hour late. So final time minus the initial time. Final time is just represented by t minus initially he started half an hour late. So minus 0.5 plus the initial location for Niram, which is 0. Let's simplify this. So the equation for Niram comes out to be 40.25 multiplied by the quantity t minus 0.5. For Olivia, general position is given by xo. Her constant velocity is minus 16. So minus 16 multiplied by the time interval. If I expand it, it would be t final minus t initial, but because her t initial is 0, I can just expand it and write it as minus 16 times any final time, plus her initial location, which is 20 kilometer. Similarly for Phil, his final location is xp equals his velocity minus 6.5 times the time interval t plus his initial location 20. Now let's look at the second part, which says at what time will the three people be located within the smallest distance interval from each other. We can see from the graph that the three people are never at the same location at the same time. When Niram and Olivia are intersecting at this point, Phil is here. And when Niram and Phil are intersecting at this point, Olivia is here. So we have to choose between these two options. If we look at the distance between these 2 points and these 2 points, we see that when Niram and Phil are intersecting, Olivia is farther away as compared to when Niram and Olivia are intersecting and Phil is closer. So the answer for the second part about the time when the three people are closest to each other would be this option. And if we read off the value of time, it is around 0.7 hours, which is equal to 43 minutes. The time t equal to 0 corresponded to 11:30. So 43 minutes from 11:30 means this time is actually 12:13 p.m. Part C. What is the length of the distance interval? The distance interval when the three people are closest to each other. So basically we have to find out this distance. We can read it off graph as well, but it might not be that precise. So to solve this third part, I would ask you to use these equations of motion. Using Phil's equation of motion, we can find out his location when the time is 0.7 hours. Similarly, by using either Olivia's or Niram's equation, we can find out their location when time is 0.7 hours. So basically we have to calculate Phil's location at 0.7 hours and Olivia or Niram's location at 0.7 hours and subtract these two locations to figure out this distance. I leave the rest of algebra and calculations to you.